Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity.
Hey everyone, today we're going to talk about something that's running pretty much all the time in the background of our lives, the critical systems that power our world. The stuff that keeps the lights on, the water flowing, and our factories running. We're going to demystify the global standard designed to keep all of that safe, IEC 62443. So let's dive right in. So here's the big question, right? How do we protect the systems that literally run our world? Because the reality is, the infrastructure we all depend on, our power grids, our water supply, it's all getting more and more connected to the internet. And while that's great for efficiency, it also opens up a whole new can of worms, a whole new world of risk. So what's the game plan for protecting these absolutely essential systems from cyber threats? At the very heart of all this are what we call industrial automation and control systems, or IACS. I want you to think of these as the digital brains behind our power grids, our water treatment plants, manufacturing, you name it. But as these systems get smarter and more connected, they also become, you guessed it, much bigger targets for cyber attacks. And that's exactly why we need a unified global strategy. And that strategy is ISA/IEC 62443. This is the global playbook for securing these critical systems. It was developed by international experts, and it gives us a flexible but really systematic framework for finding and dealing with cyber risks. Okay, so the first thing you've got to understand is that 62443 isn't just a single document or one big rule book. It's much more like a library, a whole family of standards designed to cover every single aspect of industrial cybersecurity, from the highest level policies down to the individual devices on the factory floor. The series is broken down into 4 main parts, which makes it a lot easier to digest. Part 1, General, that's where they lay out all the basic ideas and terms. Part 2, Policies and Procedures, zeroes in on the people and process side of security. Part 3, System, gets into the technical nuts and bolts for the entire system. And finally, Part 4, Component, drills all the way down to the security for individual devices. Now, what's so smart about this is how it all flows together. It all starts with those foundational concepts in Part 1. Those concepts then drive the requirements for an organization's security program in Part 2, which then tells you how to do your risk assessments and system design in Part 3, and so on, all the way down to the specific products in Part 4. It's a really logical, top-down approach. So now that we see the structure, what's the core idea, the philosophy, driving the whole thing? Well, it's this concept of the security lifecycle. And honestly, understanding this is absolutely key. This standard really hammers this point home. Security isn't a set it and forget it kind of deal. It's a continuous, ongoing process of checking for risks, putting controls in place, and keeping your defenses up to date for the entire life of a system. And here's what that looks like officially. This is the Automation Solution Security Lifecycle. You can see it's really comprehensive, right? It covers everything from the moment you start designing something to the day you finally take it offline. And this is so important because, think about it, a security flaw that gets in during the design phase, that can be incredibly hard and super expensive to fix once the system is up and running. If you build security in from the start, you get a much, much stronger system. Let's just break that big diagram down into a simple repeating loop. It really boils down to 3 steps. First, you assess your risk. You figure out your weak spots and what you need to protect. Second, you develop and implement the right security controls to protect those spots. And third, you constantly maintain and audit those controls to make sure they're actually working. And then you start all over again. It never stops. Okay, so we've got the life cycle down, but how do we actually measure security? How do we talk about it? We need some kind of common language to decide how much security is enough. And that right there is where security levels come in. The IEC 62443 standard gives us 4 distinct security levels, or SLs for short. These levels are basically a yardstick we can use to classify both the threats we're up against and how strong our defenses need to be. Let's walk through them real quick. Security level 1 protects against just casual or accidental stuff. Think of it like closing your front door but not locking it. SL2 is like locking that door. It protects against someone intentionally trying to get in, but with simple tools. SL3 is like a reinforced door with a deadbolt and an alarm system for a much more skilled attacker. And SL4, that's the bank vault. It's designed to stop a highly motivated, well-funded group with serious resources. Now, this next part is super important. There are actually 3 types of security levels. Think of it like you're building a house. Your target level, SLT, is what the building code requires. That's your goal. The capability level, SLC, is the strength of the stuff you buy, the bricks, the locks, the windows. It's what your tools are capable of. And finally, the achieved level, SLA, is how well you actually put it all together. That's the final inspection. The whole point is to make sure your final product, your achieved level, at least meets, or even better, exceeds your target. So we've got our life cycle process, and we've got our measurement scale. What's next? Well, how do we actually do the work to achieve these security levels? The standard makes this easy by organizing all the technical stuff around 7 core principles. These are the 7 foundational requirements. You can think of them as the 7 pillars that hold up any secure industrial system. Let's take a quick look at what they are. And here they are. They cover the whole spectrum. You've got the basics, like identification and authentication control, which is really just about making sure only the right people can get in. Then you have things like system integrity, which makes sure your systems and software haven't been messed with. But then you also have resource availability. And this one is huge in the industrial world. It's all about making sure your plant or your grid stays up and running, even in the middle of a cyber attack. Together, these 7 form the bedrock of your technical security. All right, we have covered a lot of ground here, from the high-level structure to the nitty-gritty details. So let's bring it all home with the one key takeaway I want you to remember. If you only remember one thing from all this, make it this. ISA/IEC 62443 is not about buying a bunch of fancy security gadgets and just checking off a list. It's about putting a methodical, risk-based process in place to make your systems more reliable, to protect their integrity, and to improve their security in a way that you can actually manage, measure, and defend. And that brings us right back to where we started. This standard is the global playbook for locking down our critical infrastructure. It gives a common language to everyone involved, from the people who own the power plants to the companies making the tiny components inside them. The plan exists. The real question is, how well are we all executing it? So the next time you flip on a light switch or turn on the faucet, it's definitely worth thinking about.
Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.